Welcome back, children. So today we are going to see our class maths. The chapter is polynomials. 9 maths polynomials. So that's chapter we are discussing so far. So up to 2.3 we have finished it. Clear. So now the new topic, factor theorem. Just before going into factor theorem, we recall what is remainder theorem. Okay, so in the last class we have discussed the remainder theorem. So just to see, this is for recalling purpose. Okay, no need to take this. So remainder theorem means when p of x is a polynomial and when it is divided by another polynomial x minus a, you know, this is p of x and this should be degree whose degree is more than the divisor. Yeah. So p of x is any polynomial when divided by x minus a, then p of a is the remainder. So how we are saying that p of a is the remainder? So the divisor is x minus a, we have to find the 0 of the divisor. For that we have to equate the divisor to 0, then we get x equal to a. Clear? So this is the way of finding what is the x, but simply solving x, that's all. So then p of a is the remainder. That means what? Instead of x a. So you substitute a. So we get p of a is the remainder. Clear? So this says the remainder theorem. And we shall see an example to understand the remainder theorem. So let p of x be any polynomial like this x squared plus 2x minus 1. Clear? When p of x is divided by another polynomial, that is x minus 1. So comparatively, the degree of this polynomial is 2 and the degree of this polynomial is 1. So the dividend degree should be more than the divisor degree. Clear? So when x minus 1 divides p of x, the remainder is p of 1. So we are saying just finding the 0 of the divisor. So x minus 1, if you equate with 0, then what we get? X equal to 1. Clear? X equal to 1. So we can say the remainder is p of 1. P of x when divided by x minus 1, the remainder is p of 1. And now we can find the value of the remainder. P of 1 is the remainder, but what is the value? That means just we have to substitute in p of x. Okay. So instead of x, put 1. So here, if you put 1, becomes p of 1 is equal to x square. So 1 square plus 2 into for x put 1 and then minus 1 is there, so as it is divide. And then we get 1 square is 1 plus 2 into 1 2 and then minus 1, then you get plus 1 minus 1 gets cancelled and the remaining is 2. So now we can say the remainder is 2. When p of x, this is x square plus 2x minus 1 is divided by x minus 1, the remainder is 2. Clear? So this we can get the same when we do in the actual division method. In the previous class itself we have dealt it very neatly, I hope. So this is the remainder. Okay, p of 1, the value is 2. The remainder value is 2. So now coming to factor theorem, when we can say the same p of x when divided by x minus a, the remainder is what? Remainder is p of a, that you know. Okay, but the value of the remainder, suppose when p of a is equal to 0, that means what? P of x is any polynomial and when divided by x minus a, the remainder is p of a, that you know. That only the remainder theorem saying. But when the remainder value becomes 0, okay, then we can say x minus a, which is the divisor, x minus a is a factor of the given polynomial p of x. When p of a equal to 0, the value of the remainder is 0, then we can say x minus a, okay, is a factor of the polynomial p of x. Clear? when the remainder becomes 0, the value of the remainder becomes 0, then we can say the divisor x minus a is a factor of p of x. Clear? So this is orally explained to you, but a proper statement I will give you, then you can take it as notes. Clear? So this is for your knowledge. Okay, no need to write this. Already we have discussed and we have taken notes about remainder theorem. So from here is not right. Clear? You see, factor theorem. So under that we take x minus a is a factor of the polynomial. Okay, is a factor of the polynomial p of x, comma, if p of a equal to 0, also if x minus a is a factor of p of x, then p of a equal to 0. You see, in both ways the statement is given. So factor theorem, to understand clearly, x minus a is a factor of the polynomial p of x if p of a equal to 0. That is what? X minus a, when dividing p of x, p of a is the remainder whose value is 0. Then we can say x minus a is a factor of p of x. Clear? So that is the first point. In addition to that, in other way, if x minus a is a factor of p of x, okay, when we say x minus a is a factor of p of x, then we come to the conclusion that the remainder is 0. That is what? P of a is the remainder. Okay, when x minus a, if you solve for x minus a equal to 0, then x equal to a, you will get. And if you put a for x, then p of a equal to 0, that is the remainder value. What it says, x minus a is a factor of p of x means, then the remainder should be 0. So this is the concept here. Clear? In both ways, x minus is a factor, then remainder is 0. Okay, remainder is 0. P of a is 0, then only x minus is a factor. So this is the way. Clear? And we shall see the problems. First sum, exercise 2.4. First sum, determine which of the following polynomials has x plus 1 as a factor. The first option, it is given. Let us take as p of x. Let p of x is equal to x cube plus x square plus x plus 1. Okay, and the common divisor is x plus 1, and they are asking x plus 1 is the divisor of all the following four polynomials, and for which polynomial x plus 1 is a factor. So for that, what we have to do, we have to find the remainder, and if the remainder becomes 0, then we can say the x plus 1 is a factor of every polynomial. Clear? So you have to take x plus 1 as a divisor. So when p of x divided by, this is division symbol, okay, divided by x plus 1, it is given in the question that x plus 1 is a divisor. Okay, when p of x divided by x plus 1, then what? P of minus 1 is the remainder. that we know by remainder theorem. Okay. How? We have to solve for x in x plus 1. So x plus 1 equal to 0, then x equal to minus 1. So this is the way finding the 0, that's all. So p of minus 1 is the remainder. If any doubt, you can write here x plus 1 equal to 0, then x equal to minus 1. Yeah. So this is in rough column we can take it. Okay. So p of minus 1 we have to find what value is coming. P of minus 1. We have to substitute here for x cube minus 1 whole cube and then plus x square. So minus 1 whole square and then plus, and x is there. So put minus 1 and then plus 1. So what happens? Minus 1. Minus 1 whole cube is minus 1. And then minus 1 whole square is plus 1. That you know. Yeah. For minus 1, if the power is even, you get plus 1. If the power is odd, then we get minus 1. That already you know. And then minus 1 and then plus 1. You see? So we can cancel minus 1 plus 1. Minus 1 plus 1. So everything vanished. So now we get only 0. So the value of the remainder, that means what? The remainder value is 0. So therefore we can say by factor theorem, what? This divisor x plus 1 is a factor of p of x. Therefore, we can say what? X plus 1, if no, you can write it. So after getting the remainder 0, we can say that therefore the divisor of x plus 1 is a factor of what? The polynomial p of x. So because we have named it the given polynomial as p of x, so we can easily write x plus 1 is a factor of p of x. Why? Because the remainder is 0. And coming to the next term, the last one, option 2 until you take as homework, the last fourth option I will do for you. So we have to take let p of x the given polynomial. So always we consider p of x only. The name is not given there, so we are assuming that p of x as a given polynomial. So option 4, the polynomial is given that x cube minus x square minus within bracket 2 plus root 2 into x and then plus root 2. You see what the question is. So this is the question, the polynomial, and we are naming the polynomial as p of x. So p of x is equal to this much I have written. And the common divisor is x plus 1. So when p of x is divided by x plus 1, the remainder is, by remainder theorem we can say the remainder is what? P of minus 1. This implies we have to find the value of the remainder p of minus 1. What happens? You see, for x cube means minus 1 whole cube and then minus, and x square is there, so put minus 1 whole square and then minus, so put minus, and within bracket 2 plus root 2 is there and then into x. So for x we have to substitute minus 1 and then plus root 2. So instead of x put minus 1 in the polynomial, that's all. Okay, and rest of the things same. Is equal to minus 1 whole cube is what? Minus 1 and then minus. This minus 1 whole square becomes plus 1. So no need to put plus. So just put 1 here. This is minus, so I put minus here, and minus 1 whole square becomes 1. So you put 1. That's all. So minus 1 again, and then minus sign is there. Okay, you see this minus sign and into this minus sign. What happens? This and this, you see, minus into minus like that. Okay, so plus will be plus, and within bracket 2 plus root 2 is there. To avoid confusion, you write, and the next step we will simplify, and then plus root 2 is there. And now you see minus 1 and then minus 1, and this is plus 2 plus root 2. So plus is before the bracket, so no change in the sign of numbers inside the bracket. So as it is we can write, and then plus root 2. So what happens you see when simplify? Minus 1 together minus 2, and then plus 2, and then plus this is root 2 plus root 2, 2 root 2, that you know. Root 2 plus root 2 is 2 root 2. In number system also we have learned it. And minus 2 plus 2 gets cancelled, and the final answer is 2 root 2. So when p of x is divided by x plus 1, p of minus 1, the remainder value is 2 root 2, which is not equal to 0. This is not equal to 0. Okay. When the remainder is 0, then we can say the divisor is factor of the given polynomial. But here the remainder is 0. So by factor theorem we can say, so the divisor x plus 1 is not a factor of p of x. Clear? This is because of the factor theorem. Remainder is not equal to 0, then the divisor x plus 1 is not a factor of p of x. Clear? So this is the factor theorem. Okay, you see, x minus is a factor of p of x if the remainder value 0. Also you can say in other words, x minus a is a factor of p of x, then the remainder is 0. Okay, so when remainder becomes 0, the divisor is a factor of the p of x. Clear? Otherwise, when we are taking that x minus a, that means the divisor is a factor, then the remainder must be 0, because this second point we will use in some other problems. Clear? And now coming to the next remaining two options 2 and 3, you take as homework. And question number 2, use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. Just you look at the question. In every option, the 3 options are there. In every options you see p of x comma g of x, like that it is given, and they are asking to say whether g of x is a factor of p of x. Clear? And you can see the degree also. Compare the degree of p of x and g of x. G of x is smaller degree comparatively to p of x. So therefore, it is correct to divide. So that is a procedure, you know. So we have to say whether g of x is the factor of p of x. And we will see one problem. Question number 2. I'm taking option 1. So p of x is given as 2x cube plus x square minus 2x minus 1. And after that g of x is given, comma g of x. I'm writing one by one, no space. So g of x is x plus 1. Okay, g of x is x plus 1. It is given like that. So what they are asking to check whether g of x is a factor of p of x. So what to do? We have to find the remainder. When the remainder is 0, then we can say this g of x is a factor of p of x. That's all. So solution. So p of x is given equal to 2x cube plus x square minus 2x minus 1. When p of x is divided by g of x we know what is that, x plus 1. Okay, then the remainder is what? G of x is what? X plus 1. So in rough column we can take x plus 1 equal to 0, and then we can take x equal to minus 1. This is the way of finding what? 0 of a polynomial. Okay, so for the divisor we have to equal to 0 and find the value of x, that is minus 1. So we can say what? The remainder is P of minus 1. Clear? So g of x is given. So you take what is g of x, x plus 1, and equate to 0 and find the value of x, that is minus 1. And when P of x is divided by g of x, then we can say the remainder is P of minus 1. Clear? So now we have to find what is the value of P of minus 1. Okay. So P of x is here. So instead of x, put minus 1. So 2 into minus 1 whole cube. You see, 2 into minus 1 whole cube plus minus 1 whole square minus 2 into minus 1 again minus 1. Clear? Just I have substituted minus 1 instead of x, that's all. And then 2 into minus 1 whole cube is what? Minus 1. So put in bracket and then plus minus 1 whole square is 1. So 1. And then minus 2 into minus 1. Minus 2 into minus 1. What do you get? Minus into minus plus 2 into 1, 2. So plus 2. So you have to focus on the sign and then the numerical also. And then minus 1 is there at last. And now 2 into minus 1. Minus 2. And then plus 1. And then plus 2. And then minus 1. So now you simplify. You see, minus 2 plus 2 gets cancelled. Plus 1 minus 1 gets cancelled. So you get 0 only. So the remainder is 0. What factor theorem says? When the remainder becomes 0, then the divisor is factor of dividend. Clear? So what is the divisor here? G of x. So here the name is given for g of x, that's all. The first problem and second problem, the difference is the divisor is named as g of x, that's all. Clear? So x plus 1, we get x equal to minus 1, then find the value of minus 1. P of minus 1 is nothing but 0, so remainder 0 means, therefore we can say g of x. That means what? X plus 1 is a factor of P of x. X plus 1 is what? Here it is named as g of x. So we can say g of x is what? A factor of a polynomial P of x. That's all. A slight variation between the first and second problem is the divisor is named as g of x. And name is given to divisor. That's all. So like that you can easily do option 2 and option 3. Okay, children. And then coming to question number 3. And coming to question number 3, it is given that to find the value of k, a constant is there. You see, in the polynomial P of x, it is given a constant k. Okay, so either the 3 terms, any term may be linked with constant. So here the constant term, the last term is a constant k. So the variable is x here because P of x. That means what? Polynomial in variable x. So x square x. So x is variable. So k is a different one. So that is a constant. So like that we have to compare and analyze. So now find the value of k. They are asking to find k, and the condition is given and the hint is given. X minus 1 is a factor of P of x. X minus 1 is a factor of P of x. That is given in the question itself. Therefore we can say the remainder is 0. If a divisor is the factor of this polynomial P of x means, by another statement of factor theorem, okay, we can say the remainder is 0. So that's the key point here. And we have to easily find k. You see, x minus 1. So given that x minus 1 is a factor of P of x. It is given in the question. X minus 1 is a factor of P of x. This implies what we can take remainder equal to 0. That means what is the remainder? P of 1 equal to 0. Clear? X minus 1 is a factor, means then we can take x minus 1 equal to 0 and then x equal to 1. So that's the way of finding 0 of x minus 1. That's all. So therefore the remainder is p of 1 whose value is 0. Why we are taking p of 1 as 0? We know when p of x is divided by x minus 1, p of 1 is the remainder by remainder theorem. But it is given that x minus 1 is a factor of p of x. So by factor theorem we can say p of 1, the remainder value is 0. So that only we are taking p of 1 equal to 0. So this implies p of 1 equal to 0 means we can substitute 1 here in the polynomial. So what happens? You see 1 square. I am substituting here. This is 0. So we can easily substitute here. That is 1 square plus 1 plus k equal to 0. Can you understand? So p of 1 is 0. That already we know because of factor theorem. It is given x minus 1 is a factor. So the remainder p of 1 is equal to 0. So this is the it is given hidden matter we have to understand. So p of 1 equal to 0. Therefore p of 1 just we substitute what? 1 instead of x. That's all. So 1 square plus 1 plus k equal to 0. So this 0 how we got? By factor theorem. You can say by factor theorem. The reason by factor theorem we can write that the remainder is 0 because x minus 1 is a factor of p of x. It is given in the question. So this implies 1 square is 1, again plus 1 plus k equal to 0. Then this is 2 plus k equal to 0. Therefore k equal to minus 2. So just they are asking to find the value of k. We found that. Clear? And coming to option 2, okay, there are 4 options given and I will do for you 2 and remaining 2 options take as homework. So you see that option 2, what is given in option 2? Same question number 3, option 2, thus p of x is 2x squared plus kx plus root 2. Okay, this is what given here, and you have to find the value of k. See, in this question, k is in the last, there is a constant. So here the k is a constant, but it is the coefficient of x. Clear? So I already told you, the k will be any value. Okay, sometimes here instead of 2, k may be there. So like that, we have to find k, that's all. So the same way, given that what x minus 1 is a factor of p of x, it is given in the question. So we can take that the remainder, what? The remainder is 0. So the remainder is what? P of 1. Already told you. X minus 1 means you get x equal to 1, then p of 1 is the remainder. So p of 1 equal to 0. Clear? The remainder is 0. This implies if you substitute 1 for this polynomial, what happens? 2 into 1 square plus k into 1 plus root 2 equal to 0. Clear or not? Already we know the remainder is 0. How? Because the divisor x minus 1 is a factor of p of x. It is given in the question. So directly we can equate to 0. What happens now? This implies 2 into 1 square means 1 only. 1 square is 1, so 2 into 1, 2. Simply we can write 2 plus k into 1, k. And then plus root 2 equal to 0. And you see 2 plus root 2 in left side. So just to take, that is transposing to the right side. What happens? K is equal to minus 2 minus root 2. This implies k equal to, so this is correct, but both are negative. So commonly we can take the negative sign and then we can write like this, 2 plus, you see, minus of 2 plus root 2. Okay. So when we remove bracket, we get minus 2 minus root 2 also. That only. So this is the value of k. So the remaining 2 take as common. So now, before going to fourth question, we just recall what we have learned in 8th standard, factors. Okay, factorization. So put star and write factorize x square minus 5x plus 6. So this is a polynomial and this is quadratic polynomial. Okay, so we have to factorize it. So by splitting the middle term, so this is the method here. So by splitting the middle term, what is the middle term? Minus 5x. Okay. So using that, we are going to factorize this. So for that, product value and sum value, I think you know. Capital P, product value, capital S, sum value. So like that we take it. Okay. So the product value means what? Coefficient of x square is what? 1. Coefficient of x square is 1 and the constant is plus 6. Okay. If it is minus 6, you have to take in account minus also. So here plus 6. So 1 into 6, that is 6. Clear? Clear or not? And sum value means the coefficient of the middle term, that is x. So coefficient of x is minus 5. Yeah? So you have to just write this and then you know this, I think. Let's see method. 6 product value minus 5 sum value. You know how I got the product value? 1 into 6. 1 into 6. You get 6. Product of coefficient of x square and the constant. 1 into 6. So we get 6. That is the product value. And sum value is the coefficient of the middle term x. So minus 5. If there is minus, you have to take in account minus also. So product value and sum value. Product value you just write on the top and bottom sum value. And you are splitting in a tree method. Okay, 2 numbers you have to find whose product should be 6 and whose sum, the same number sum is minus 5. So for that we need to know the factors of 6. Factors of 6. For example, 1, 2, 3, 6. So these are the factors of 6. Okay. So among this, which is applicable here? So if you take 1 and 6, 1 into 6 is 6, that you know. But the sum, 1 plus 6 7. But here minus 5. So you take 3, 2 or 2, 3, right? Yeah, 2 and 3. So if you multiply 2 and 3, you get 6. And if you add, you get 5. So first you choose the number and then you correct the error for the sign. You see 2 plus 3 means 5, but here minus 5 is the sum value. So for that, if you put minus here, both 2 and 3, then you add minus 2 plus minus 3. The sum of minus 2 and minus 3, you get minus 5. I think you have clear now. Okay. So minus 2 into minus 3, if you product, okay, if you multiply minus 2 and minus 3, what do you get? Plus 6. You see the product is plus 6. And here the sum, when you add these two, you get minus 5. So this is the method to find to split the middle term and the way of finding the factorization. Yeah. So now minus 2 and minus 3 on that. So splitting this, we can take x square minus 2x minus 3x. This middle term only we are splitting. So these numbers we found by this tree method. So minus 2 minus 3 means we can take as minus 2x and minus 3x. Okay. If you add, you get minus 5x and then plus 6. So these are the rough work. Okay. So this is splitting. Minus 5x is splitted as minus 2x minus 3x. Clear or not? So now you in first 2 terms. Now 4 terms after splitting, it becomes 4 terms. So first 2 you take x as common. That only you have to take. So x as common, then you get x minus 2. Clear or not? If you multiply also, you get the same. You can check x into x square, x into minus 2, minus 2x. And coming to the last 2 terms, you can take 3 outside. Am I right? 3. So if you take minus 3, what happens? If you take plus 3, then minus x will come in the bracket. But you can have one idea, that is the next two terms, the same x minus 2, in the product, the same x minus 2 should come. So that is the one tips. So minus 3, if you take out, then x will come. You see, the same x is here inside the bracket. And then minus 2 will come. You see, minus 3 into minus 2. Product of minus 3 and minus 3 into minus 2. That only you will do. So minus 3 into minus 2 plus 6. Correct or not? So the same terms, x minus 2, here also x minus 2 inside the bracket. That also you have to check. Clear? So these are the ideas. And then in this product, we can take x minus 2 as common. Clear or not? So after taking x minus 2, what is there? X. So you write x into bracket x. And then after taking x minus 2 as common, the remaining is minus 3. So minus 3. You see, factorization is nothing but product of two polynomials. You see, this is a quadratic polynomial because degree is 2. And the factors, you see, this is one linear, this is one linear. So product of two linear polynomials. Clear? So a quadratic polynomial is splitted as what? Product of two linear polynomials. This is the factorization. So simply you can say 10, you can write as 2 into 5 or 5 into 2. So like that 2 and 5, both are factors of 10. You know. So 2 into 5 is 10. So like that, this is written. Okay. So this polynomial is nothing but the product of these two polynomials. So this is called factorization. Factorization means what? In product we have to write. That is called factorization. So this is the factorization by splitting the middle term, which we have learned in 8th standard. Clear? And now also the same type of problems will come. You see in 2.4, factorize question number 4. Factorize option 1, it is given what? 12x square minus 7x plus 1. 12x square minus 7x plus 1. So here you see the coefficient of x square is 12, whereas here the coefficient of x square is 1. So that's the difference. So anyhow, we have to multiply the coefficient of x square and the constant. So 12 into 1. 12 into 1, 12. So we can take the product value p as 12 and the sum value as, the middle term is minus 7, coefficient of x, that is minus 7. And now P method we can use. Clear or not? So any two numbers, when you multiply, you should get 12. And the same two number, when you add, you should get minus 7. What are they? You see, 4 and 3, you know, the factors of 12 we have to find. The product value, we have to find the factors. So 1, 2, 3, 4, 12. These are the 6 also comes. But here, which is applicable? That is the matter. Like that we can write. And which is applicable, you have to choose. So 4 and 3 we take. 4, 3. You know, 4 and 3 if you add, you get 7. And you multiply, you get 12. So this is the thinking. By thinking and finding the factor, using some tips, easily you can find. This is logical thinking. By practice it will come. So 4 into 3 you get 12 and 4 and 3 get plus 7 if you add. But here it is minus 7. What to do? So you put minus for both numbers. And here also, if you product, you get minus 4 and into minus 3 you get plus 12. And if you add, you get minus 7. Here. So this is what we have to be going to do here. So just split minus 4x and then minus 3x and then plus 1. You see? Clear or not? You see, the middle term is returned. Now, from these two, now it is 4 terms. So from these 2 terms, you can take the numerical also as constant. Which one? 4. Because here 12, here 4. the lower value only can take as common. So 4 we can take out, and then x square, x means x we can take out, and what will be the remaining? Here 3 will come, because 4 into 3 only 1. For x square, if you take x out, then x is the remaining, so 3x will come. It's clear? Is it clear or not? So, and then put minus 4x. The 4x itself taken as common. Then what will be here? 1. The 1 will play a role here. 4x into 1, that is minus 1. 4x into minus 1 minus 4x. That's all. So, the number 1 play a vital role in many areas in maths. Clear? And then here, if you take minus outside, what happens? So 3x, because here I already told you the bracket terms should be equal. Okay, so here 3x means here also you should get 3x, but minus 3x means put minus, and within bracket you can put 3x, but here you have to write 1. Here also 1 plays a role, you see, major role. No change. If you put 1, minus 1 into 3x is what? Minus 3x. And then this plus 1, but here in the bracket is minus 1. So put minus 1, then you can check minus 1 into minus 1 plus 1. Clear? If you can write 1 as what? Minus 1 into minus 1. That you know. So here minus 1 is taken outside. Therefore, inside the bracket you have to write minus 1. Minus 1 into minus 1 plus 1. So no need, but for those who can't understand, just I am explaining. This is the way. So you see, here and here are both terms. So from this two product, okay, 3x minus 1 we can take. From this two product, we can take 3x minus 1. So 3x minus 1 you take common, and the remaining you can put in another bracket, it is 4x and then minus 1. You see, 4x into 3x minus 1. So if you multiply, you get 4x into 3x minus 1, and then minus 1 into 3x minus 1. So minus 1 into 3x minus 1. Like that in the bracket. So the product of two linear polynomials, you will get this one. So the product, that is called factorization. If you give in product of two polynomials, that is the product. That is the factor. Clear? So each one is a factor of this, because this polynomial is equal to the product of these two. Therefore, what we can say, each one is a factor of this polynomial. So that is what here comes. Clear? And now the rest of the sums can be as homework. Okay, very easy only. Other three options are there. Okay, you just try the same way, you will get. Okay, easily answer. And coming to the next part, question number 5. And now coming to question number 5, this is also factorization. But what is the difference? The fourth sum only quadratic polynomial, this second degree polynomial only given, but here cubic polynomial. So all the four options are there. So I will do for you 2 options, the remaining homework. Okay, out of 4, I will do 2. So all the 4 options, the given questions are cubic polynomial. So cubic means what? You know, the degree is 3. So as per the degree, the factors will be there. For second degree, we got 2 factors. Here, what? X cube, that is the exponent, highest power is 3. So degree is 3. So for cubic polynomial, how many factors will be there? 3. Yeah, almost 3 factors will be there. So we have to find the factors of this polynomial, and this is given as x cube minus 2x square minus x plus 2, and we are naming it as we are assuming that let p of x is equal to, okay, so given polynomial. And here how to how to factorize this. So a few steps or few tips I will give you. So take in account everything, observe carefully. First of all, we have to observe the coefficients of all the terms given in the polynomial. You see, 1, and then minus 2 and then minus 1 and then coefficients alone. You see, sum of the coefficients of the given polynomial. You see, this is 1 and then minus 2 and then minus 1 and then plus 2. What you get? 0. So the sum of the coefficients of the given polynomial is 0. Therefore, we come to the conclusion x minus 1 is a factor. Can you understand? This is one clue. If the sum of the coefficients is equal to 0, we can come to the conclusion x minus 1 is a factor of the given polynomial. Otherwise, if this is not equal to 0, then what we do? What you have to do? X plus 1. If it is equal to 0, what? Sum of the coefficients, then we can say x minus 1 is a factor of p of x. Clear? Otherwise, you try for x plus 1 is a factor, like that. We have to move. This is trial and error method. By trial and error method only, we can find one factor first. And after finding the first factor, the polynomial, cubic polynomial becomes the product of a linear and quadratic. Then you know how to find quadratic polynomial, how to factorize as in the question number 4. Clear? So like that we will see what happens now. So by this clue, I'm coming to the conclusion that x minus 1 is a factor. So by trial and error method, I am trying. When p of x is divided by x minus 1, what happens? P of 1 is the remainder. Clear? Is the remainder. So I am trying to find whether the remainder is 0 or not. This implies p of 1 equal. If x minus 1 is the divisor, then p of 1 is the remainder. Then you know how to find x equal to 1. X minus 1 equal to 0, then x equal to 1. So just input 1, that's all. P of 1 is the remainder. By remainder theorem we can say. So just find the value of the remainder. P of 1 is equal to 1 cube minus 2 into 1 square minus 1 plus 2. And what happens now? 1 cube becomes 1 minus 2 into 1 square is 1 only. So minus 2 into 1, 2. And then here minus 1 plus 2. You see what happens? Plus 1 minus 1. Minus 2 plus 2. What happens? 0. So we come to the conclusion that x minus 1 is the factor because p of 1 is 0. Therefore, x minus 1 is a factor of what? P of x. Clear? You can write like that. By trial and error method, having some clues, we can easily find one factor. X minus 1 is a factor. Further, we can put bracket. X minus 1 is a factor of p of x. You know, suppose if you are not getting the sum of the coefficients is equal to 0, if not 0, then you try for x plus 1 is a factor. Then p of minus 1 will be the remainder and you substitute minus 1 instead of x and you see what happens. So this is the trial and error method. Okay. Now we got x minus 1 is a factor of p of x. And after that we can write p of x as by dividing p of x by x minus 1. This is just we are finding the remainder. After coming to the conclusion that x minus 1 is a factor, we divide by actual division method. You see, I'm doing here because the space is not enough. So x cube x cube minus 2x square minus x plus 2. Okay. And I am writing here x minus 1. And by actual division, we try to find the quotient. The remainder already 0, then only coming to the actual division. Okay, so x minus 1, when you divide p of x by x minus 1, here comes x square, that we know how to get it, because the first term x cube by x, what you get, x square, that we know. First term of the dividend by first term of the divisor, you get x square, so you put there. So we multiply x into x square, sorry, x cube, okay, and then minus 1 into x square, minus 1 x square, like that we can take. And usually I try to tell you that below the bottom terms you have to put a line leaving some space. Here you have to change the sign. Within bracket you have to put. So x cube minus x cube gets cancelled, and then minus 2x square plus x square. Now we have to consider this as plus. So plus x square. What happens? Minus 2x square plus x square is nothing but minus 1x square. So I am writing as minus x square. Clear? I have explained you, and also why we are. I have told you the reason why we are changing the sign in the bottom terms. You observe, okay, you see the what we have explained in the number system when we divide, okay. And now coming here, minus x square, and then coming to the next one, minus x, okay. And now the first here, minus x square, and always the first term of the divisor is x, so you get minus x. Am I right? X square, here x. After cancellation, you get minus x. So you put minus x there. So x into minus x. You have to multiply this x minus 1 with minus x alone. So x into minus x, we get minus x square. And then minus 1 into minus x plus x. This becomes plus, this becomes minus. Change the sign. And first term always gets cancelled. And minus x, minus x. So minus 2x. Clear? And the last is 2 plus 2. And here minus 2x by x. What do you get? Minus 2. That you know. So put minus 2 here. And you multiply x minus 1 with minus 2. What do you get? X into minus 2. Minus 2x. Minus 1 into minus 2 plus 2. So put plus 2. And what happens? The same terms are there. So you see x cancel. 0 you will get. This is 0 only comes because already we have found that p of 1 is 0 and x minus 1 is a factor. So since x minus 1 is a factor, the remainder is 0. Why we have did this actual division? To find the quotient. For this only we did this. Clear? And now we can write this implies p of x as what? X minus 1 is one factor, and then the quotient you have to write x square minus x minus 2. You see, the cubic polynomial is split as the product of linear and quadratic. So again we can factorize this by the previous method, splitting process, middle term. So again you get 2 factors, totally 3 factors. Now you see x minus 1, now I am changing the bracket, I am writing as x square minus 2x, the middle term is split as minus 2x plus 1x. So plus 1x is x, no need to put 1, clear? So like that the middle term is split, x square, the middle term minus x only is split, minus 2x plus 1. This is the splitting the middle term, and then minus 2 last. And you see now x minus 1, and here the first 2, if you take x common, what you get? X minus 2. Clear? Already we have seen everything. And then plus, in this x minus 2, as it is in the bracket, x minus 2. So put 1, that's all. So I already told you 1 play a vital role wherever needed. So here if you put 1 and write x minus 2 as the same, because nothing we can take common in this x and minus 2, only 1. So that is the highest common factor of x and minus 2, you know. So that you know. So x minus 2 plus x minus 2, in these two terms we can take 1 as common and the remaining we get only the bracket x minus 2. So now here also x minus 2, here also x minus 2. So you can easily take that as common. You can remove the bracket. You can again change. So x minus 2, if you take common in both, you see plus sign is between them. So in this product take x minus 2, then we get what? X is the remaining, and then here plus 1. Here, and we can write now x minus 1 into x minus 2 into x plus 1. There. So now product of three linear polynomials. Clear or not? Linear into linear into linear, which is equal to cubic polynomial. So now the same p of x, okay, is factorized as product of three linear polynomials. So one we already found by clue, and now this is the way of finding by actual division. After getting the quotient, you find the factor of this quotient alone, and you proceed by keeping the first x minus 1 as same, and only the change is here, and you get another 2. So totally 3 factors of this cubic polynomial. And now coming to another sum, that is option 2. It is given x cube minus 3x square minus 9x minus 5, and we just assume let p of x, okay, equal to x cube minus 3x square minus 9x minus 5. So here when we apply the first clue, what sum of the coefficients? So by seeing itself this sum, the coefficients, easily say x minus 1 will not be a factor. You see here 1 and other numbers are minus 3, minus 9, minus 5. So plus 1, only 1. Plus value is only 1, that is 1. So 1, minus 3, minus 9, minus 5, definitely you won't get 0. Sum of the coefficients is not equal to 0. Therefore definitely x minus 1 is not a factor. That we come to know by using that clue, what I told you in the previous sum. So now another method I will tell you. So what is the constant here? Minus 5. So just to take as 5. So factors of 5 you can take. Factors of 5. What are they? 1, 5. 1, 5, that's all, you know. Or by prime factors itself you can find. So 1 and 5 are the factors of 5. So if you take 1, then 1 will not come, because we know x minus 1 is not a factor. Clear or not? So better try for 5. So you when try for 5, x p of x is divided by x minus 5. The remainder, this is a right of rough work. The remainder is c of 5. Clear? Here 1 and 5 we are taking. If 1 take means, then we will get x minus 1 as a factor. The x minus 1 factor will not come. Just we apply that clue, sum of the coefficients, which is not equal to 0. So try for 5. So x minus 5. Just the trial and error only. Now find the value of the remainder p of 5. You just put 5 instead of x. So here 5 cube minus 3 into 5 square minus 9 into 5 minus 1. You see children, 5 cube is nothing but 125. You know 5 into 5 into 5 is 25 into 5, again you get 125. And then minus 3 into 5 square is what? 25. And this is minus 9 into 5, 45. Minus 45. And at last minus 5. And you see 125 minus 75. 3 into 25, 75, so minus 75. And then these two minus 45 and then minus 5. You see 125. All these three, okay, except 125, all the three are negative. So you just add all the negatives. What you get? This you get 50 and 50 plus 75, 125. So minus 125. So now 0. 125 minus 125, you get 0. Therefore, we come to the conclusion that what? X minus 5. Since the remainder is 0, when the P of x is divided by x minus 5, then we can say x minus 5 is a factor of the polynomial which we named as P of x. So, by trial and error and with some clues, we have found that x minus 5 is a factor of P of x. Clear? So, what to do next? Just you do actual division. Okay, so divide the P of x by x minus 5. That's all. So, x cube and then minus 3x square and then minus 9x and then minus 1. You just divide by x minus 5. Clear? Because x minus 5 is a factor. So, x cube, here x, what we get? First term of the dividend x square and the divisor is x, so you get x square. So, you put x square here. And here you get x cube and then minus 5 into x square minus 5x square. You leave some gap and put the bottom line to change the sign. So x cube minus x cube gets cancelled. Okay. And then minus 3x square plus 5x square. So this is plus 5, this is minus 3. So the sum is 2x square. You get that one thing. And then minus 9x is there. So brought in, so bring it down. 2x square minus 9x. And then first term of the dividend is 2x square. So you put 2x square by x. What you get? 2x. Clear or not? Cancel 1x in the numerator and denominator, you get 2x. So plus 2x you have right here. And now you have to multiply x minus 5 with 2x. So x into 2x, what do you get? 2x square. Minus 5 into 2x, minus 10x. And again, change the sign. So first term, cancel. No need to strike it. Okay, this means that it becomes 0, that is cancel. And now minus 9x plus 10x. So plus 10 minus 9, like that we have to take. Plus 10 minus 9, but you get 1. So no need to put 1. So just you write x and bring minus 5 now. Clear? Now the first term of here is x. You get 1. X by x, 1. X, x. So x by x, 1. So put 1 here plus 1. Clear? And you multiply x minus 5 with 1, you get same x minus 5 and is nothing. Sorry. Here becomes minus and here plus. So 0 you will get. Already you know when x minus 5 is a factor, the remainder is 0. That only comes. By this we can easily verify our division is correct. So now with quotient we have to write. This implies P of x is equal to x minus 5 is one factor and the second degree we have to write the quotient x square plus 2x plus 1. Clear? So now you have to factor this. Keeping this as same, you have to factor to get another two factors. So here comes x square coefficient is 1, here also 1. So 1 into 1, 1. So product value is 1 and the sum value is what? 2. You see? So 1, 1. So 1 into 1, 1 and 1 plus 1, 2. Clear or not? So now we can easily say by splitting the middle term, just write like plus x plus 1. You see how I am writing? And now x minus 5 is the same. And first 2 you can take x common, so you get x plus 1 and plus 1 into x plus 1. Clear? In the last 2 also no common terms, so take 1. 1 play vital role, so 1 into x plus 1. Just put 1 and in bracket x plus 1, that's all. And you see now x minus 5 into here x plus 1 take common, and the remaining is the first product is x and second product is 1, that's all. And you can write by removing the square bracket x minus 5 into x plus 1 into x plus 1. You see now the product of three linear factors we have found. So p of x is the cubic polynomial, and you know that there will be three factors. So now we have found the product of three linear factors of the given cubic polynomial. So this is the way to find the factorization of the cubic polynomial. And two more options are there. Please take as homework. You practice a lot, then only you can come to understand better. And the worksheet will be sent to you for both 2.3 and 2.4. So please then and there you finish the worksheet also. Thank you, children.